And welcome to Ladyada.
Hey everybody, and welcome back to my desk. It's me, Ladyada, at my desk, doing a slightly different video setup, but hopefully all will be working out awesome. This weekend we did a lot of work on iMX RT Metro, which is a product that I was totally amazingly ready to release around January of 2020. And I was working on it, and then like things kind of like went downhill, and then I couldn't get chips, but now I can get chips. They're totally available, and I thought I'd show, I'm kind of like reviving it because we had it coming soon in the store. We even got CircuitPython, bootloader, everything working, and just like it's just really bad timing on the Metro's part. Not its fault, it's just how it is. So let's go to the overhead, and I'll show off this board. So this is just me. Well, this is CircuitPython. It's just doing a little graphics test here. And this is the, hold on, let me just move the overhead up a little bit. So this is the Metro, so what it looks like. And I like this shape. It's basically Arduino pinout compatible. It's got SPI port over here. The iMX RT1011D, which is the chip we're using. I'm using ESP32 as a coprocessor, so this just does Wi-Fi support through CircuitPython and works pretty well just over SPI, so you can get TLS 1.2 security. So you've got the header, so you can, as you saw, I plugged in the shield. The shield's a really good way to demo because it's got SPI for the TFT and micro SD, and then I2C for the touchscreen. So, using this is good to test both at the same time. It's got SWD because it's a Cortex M7, 8 megabytes of flash, USB-C, NeoPixel over here, reset button, and then 9 to 12 volt DC jack with an on-off switch. So, your standard Arduino pinout. It's not going to be green. It's going to be probably purple in the end. And the nice thing about this iMX chip is it's got enough pins basically for all the Arduino GPIO plus, the couple extra you need, the 3 for SPI, I2C, and then a couple extra GPIO for controlling the ESP32. And so far, it actually worked really well. Again, it 3 years ago, it was working great. And then it just like kind of had bad timing, and it just got dropped in the excitement of COVID, and then I couldn't get chips. NXP was hard hit. Like if you had NXP parts in your design, it's been really rough for you. So my sympathies. But like I said, I just randomly checked to see, hey, can I get these again? And it's like, hey, they're totally in stock at Digi-Key. So like, let's do this thing. So the thing I worked on this weekend, which is the kind of the most important thing, is to get the tester going. And people who watch Desk Ladyada know, like, the tester is, it's the second design. The first design is the board, and the second design is how to program it. So the easiest way for me to program boards is with an Arduino. So like this is an Arduino based tester here. So this board has pogo pins, and I program it through an Arduino IDE. But the second best way for me to program stuff is with a Raspberry Pi. I'm recycling. This is not ESP32S2, obviously, but it's just I had this tester lying around, and so I have it hooked up to the USB-C. This USB-C goes to the Raspberry Pi, which is, basically the thing is that if you have any test code that can run on Linux. I used to have, anything with an ARM Cortex, I used to program with a J-Link. But J-Links are kind of expensive, and honestly, they're reliable, but they're like not always as fast as whatever's built in. Luckily, lately, a lot of the chips that we've been using, like the ESP32 and the RP2040 and the NXP, have built-in ROM bootloaders. Thank you, industry, for having USB ROM bootloaders. It's been NXP actually was one of the first companies to do built-in ROM bootloaders with mass storage. So big props to them. All you have to do is set these boot select switches. So there's 2 switches, and there's, I think, only 3 modes. One of the modes isn't used. But one mode, if you have the switches the opposite of way that I have them now, it puts it into USB ROM bootloader, and then you can again bootload it over USB. It shows up as like a HID device, and then you can switch the switches back, and it will boot into whatever's programmed into the flash. To load the code onto the NXP chip, you use this program called SDP host. So let's go to the computer and I'll actually show this because it's handy to know.
Do
So,
you have questions while you do this, or you want to wait?
yeah, just throw them at me. And
Okay. What does the iMX offer compared to the SAMD chips or the RP2040?
Massive speed. It's a Cortex M7, so the core itself is much faster. It has like more instructions, like the M7 instruction set can do more. So if your code is compiling to M7, you're going to get that benefit. It's got a ton of RAM, 128K of RAM. And it's got a lot of megahertz. You want hertz? It's got mega, 500 of them. So 500 megahertz, not overclocked. That's just like right out of the box. Whereas the RP2040, the Cortex M0 Plus, running at about a 130 megahertz. I mean, you can boost it up to, you overclock it to 250, but you know, it's 130 is what it's spec'd at. And the SAMD 51, I think, is also 120. That's a Cortex M4, and you can boost that up to like 200. But again, we're talking about orders, you know, almost an order of magnitude more speed, 5 times more speed. So for uploading code, thankfully, there is a cross-platform tool that NXP wrote called SDP Host. Like, yes, again, thank you for making it cross-platform and not Windows only. There is a Windows GUI tool, and it's totally weird. This command line tool is easy to use. It's documented over at NXP under SP SDK. It supports Python 3, does not require 2.7. Again, thank you so much. A lot of chip companies are still using 2.7. Thankfully, many have in the last decade finally moved to 3. So SDP host allows you over USB or UART to upload code to, again, that ROM bootloader. Once you load that code, and we have actually a guide on this because I keep forgetting how to do it. And in fact, while I was working on the tester, I forgot, and then I forgot that we had this guide. But anyways, you get these jumpers, you set the jumpers, and it shows up as this, HID device. And then you run SDP host, you tell it to write the file to this memory location, which is an SRAM. So another thing I was a little confused about, the bootloader does not write to flash. The bootloader only writes to RAM, but then you can have your program that you're loading to RAM write the flash. So you have like a stub, which actually kind of makes sense because like the QSPI memory might have initialization and you don't know what it is, and the bootloader may not know about it. So the bootloader runs from ROM, does not know about the QSPI flash. You load through SDP host into SRAM, right? That's the 2020 address start. And then you see it load, this binary file. This is just wrapped over. And then you tell it to jump to the address. This is after the right address because this is after the interrupt vectors. You tell it to jump there, and then the binary that you uploaded actually will initialize the flash and write the second stage bootloader, the TinyUFT bootloader, into flash. And so, if I have this board, I just double clicked it, and this is what it shows up as, Metro M7. And then you get the UF2, the index HTM that takes you to the store, and then the info, which tells you, hey, this is a Metro M7, Rev A. So that's the second stage bootloader. Because again, this bootloader is always in ROM, but it's a little bit like funky and weird, and we like our second stage bootloader. So
Okay, what IDE would this work with? MCU, microcontroller, Espresso?
yeah, you would definitely be able to use this with MCU Espresso. Yeah, Espresso. Except I also had to write, so we had to do three things. So one, you have to load the bootloader, which we use with the SDP host. The Raspberry Pi, again, we have a compiled binary already done. It turns out compiling the binary is a little annoying, but we've compiled the binary for Linux for ARM X7, whatever, 64. It's available in the GitHub repo here. So we have bins. Please just use the bins. Don't do what I did, which is like, I'm going to compile it. No, it turns out it's like a total nightmare to compile. Windows and Mac, you can pip install it. Maybe it's not so bad, but on Raspberry Pi, don't. Then what we do is we load in the ESP32 programmer. So this is an NXP Espresso program that toggles the GPIO for the ESP32 to get it to bootloader mode, and then takes CDC data and pushes it to the UART and vice versa, right? It creates a USB to UART converter to the onboard ESP32 so that I can run ESP tool on the Raspberry Pi, and it's like seamlessly thinks like I'm just connected directly to an ESP32, and I can program the Nina firmware, which is the Wi-Fi coprocessor. And then the third thing I have to do is I have to test the board itself. And so I have a new program. So I actually kind of learned an XP Espresso code over the weekend because I was like, well, I have to write the code to test the pins. And the way I do that is I have two pins that are not physically next to each other tied on the test board. And then I, pull one high and I test if it's high, and I pull it low and I make sure it's low and make no other pins are shorted. And that's a great GPIO test. It works wonderfully, and it just catches bridges and makes sure that there's no cold solder joints. But like there's no Arduino core at this time for this chip. I don't know if we'll write one. I looked at RT1011, kind of everyone sort of just writes NXP Espresso. And like I said, we have CircuitPython. I don't load CircuitPython on purpose because whenever I've done that and shipped people CircuitPython, it gets out of date so quickly because we do so many revisions that people have issues with updating and they think they have the latest version, and it's very hard for me to keep it up to date. So I'd rather have the test code be in C. It runs very quickly, and then when people get the board, it works, and then they can load CircuitPython. So I made like a really quick, like Arduino-ish core. And this is in the TinyUF2 repo, so it's hidden behind this. But it's in github.com/Adafruit/TinyUF2 in the new Metro 7 branch. So all the pins, and this is like the GPIO and MUX details, and whether it has ADC, and then I kind of made like a fake printf to, this USB serial. I made a fake millisecond timer, fake delay, a thing to help get the pin map, digital write, digital read, pin mode to, set the digital in and out for the pull-ups and reading and writing so I can check the GPIO. I started on the analog read, but I'll say actually I didn't get quite far with this. I'm missing some include, and there's like 3 different ADC includes, and I'm like, I'll figure this out later. It's not important. I didn't need this to kind of get started. I can always, get that going before I ship the hardware. And so then I load, I have this quick like this function that I use to test pins that tests all the pins and the pull-ups and everything. I could copy it right in. And it tests all the pins. Then it says okay. And if it isn't in test mode, it does a NeoPixel swirl. Oh, this is actually not the latest version. Shoot. Okay, this is not, the code's not here. But there is RGB write, so it does I added a little NeoPixel swirling animation. So let's go to the overhead, and I'll do a quick final demo of this just to show what it actually looks like when I'm running it. So the board is loaded in, and now it's hooked onto something. It's loaded in. I'm gonna have a pogo pin for this. This, like I said, the boot switches have to be changed to enter into the bootloader. This is the reset. So I only need 2 jumpers, 2 pogo pins that will go to the Raspberry Pi. And which is the nice thing about the Raspberry Pi is it has USB, but it also has GPIO, so it can like toggle things for you. So the first thing it does is it resets, it burns that TDF2 bootloader. It loads in the ESP32 programmer, and then that's running ESP tool. And one thing that's nice about running ESP tool on the Raspberry Pi is it compresses the firmware because it has this, can do the stub loader. So it's much faster than programming it from memory. Then it runs that test I showed you, and it says test okay. And we're good to go. 26 seconds, and then this is that NeoPixel swirl, and the red LED is blinking. So that's it. Like, all hardware is tested, and chip's good. ESP32 is tested. USB is tested. This is pretty, and then I also test the DC jack with a voltage divider once I get the analog read going. And this is good to go. So like these chips These are my samples that have been using, but now I have a reel of them. So I'm super psyched to get this board out the door. And then what's funny is I actually have, when I first started this, we were going to do a feather, and I actually, from what I recall, we contracted Arturo, who has a company, Electrons, I think it's called now, or maybe no, it's called something else, which I can't remember. And also a company named Electrons, and he designed for us this really cool feather M7. So this is, we're going to be able to release this as well. He did an awesome job with that. Looks familiar. That's that Molex micro SD socket that we've been using lately. It's double-sided, but we might actually convert some of these parts to 0402. This is definitely a 4-layer board, I think, or maybe even a 6-layer. But we can convert some of these parts to 0402. Also, if you remember from the RP 2040 Bones video, we found some smaller versions of some of these components. We can squish this down, and I don't know if, we wouldn't be able to move the micro SD card to the top, but we might be able to move these capacitors. So like, you could have a version without the micro SD card if you wanted a super flat version. So I'm super psyched. This looks great. And, now we have parts available. We can actually get this. This
Does
is in
it
the
use
future.
the internal 500 megahertz clock or external crystal?
There's a crystal. It's right there. You can see it here. And then you can see it here. I think it's a 24 megahertz, and there's a phase lock loop inside. So that's that. So
Cool.
any questions before we move? I know I wanted to slam
Yeah,
around.
keep going.
Okay, let's move on to Great Search.
Alrighty, here we go.
Where in the world is that part I need? The Great Search with Digi-Key.
The Great Search brought to you by Digi-Key and Adafruit. Thank you so much, Digi-Key. Every single week, Ladyada uses her power of engineering to help you, yes, you find the parts that you need. Lamore, what are you looking for this week on Digi-Key.com?
Okay, I wanted everyone to know that this week that the iMX RT series chips are back in stock at Digi-Key. Not every single one of them, but the ones that I'm looking for, the RT1011D. But I also wanted to show all the different kinds of iMX RT chips, so you can decide which ones are for you. And I also have a couple of samples here that I can show off so people can see, like when I say BGA, how big is the BGA? When I say QFP, how big is the QFP? So let's go to the computer. Don't forget, if you are using iMX, we have a little tutorial on how to install the TinyUF2 bootloader, second stage bootloader, that we publish on GitHub to your iMX board. So like I said, the chip that we're using, there's the iMX RT 1011C and the 1011D. The 1011C runs at 400 megahertz. The 1011D runs at 500. I love more hertz, so I'm going with that. And then if you're like, what's the difference between these? This link, which we'll post in the video, and also you can just Google for iMX crossover MCUs, and it's on NXP's website. You can see that they tell you the difference. It goes from most complex to least. And there's some good stuff. So let me tell you some of the differences here. Like I said, we're using the 1010 series. So it's a little confusing because it's called the iMX 1010, but there is no actual iMX 1010. I don't believe that actually exists. There's the 1011. It's like, you know what I mean? There's like a series called the 1010, but the actual component is called the 1011. Let me see if they have the part number here. I think, hold on. Yeah. So these are the parametrics. Okay. So you can always go to NXP site if you want like more details, because they'll have like the exact, perfect setup. So the C series, 400 megahertz. Whoa, didn't want to buy that. 400 megahertz. Both have 128K of SRAM. If you want more SRAM, I'll show you the next series. 2I2C, 2SPI, 4UART. Unlike if you're used to some of the chips like the NRF52 or the ESP32, where you can kind of like move whatever peripheral around, that's not true. The pins are set, not set, but there's you can't put them on any IO. There are like chunks that are like UART and I2C and SPI, so you have to mux them out. That's not unusual. There's a lot of pins available, but they're not super fixed like the Sam, the at Mega 328, and they're not super flexible like the NRF 52. Both have 16-bit PWMs, both have ADCs, no DACs. Looks like the C series has a slightly wider temperature as well. So slower, but wider temperature range. Both are LQFP 80. If you're like, oh, I like the 1010, but like I want more RAM, the 1020 is kind of the next update. That has, if you just want more pins, you can go to the 1015. That goes from an 80 to 100 LQFP. So you probably get like another 16 GPIO, still 128K RAM. The 1020 is the big leap to 256K RAM. And then the 1024, this is actually interesting. I think we covered this on IMPI when it came out. The 1024 is exactly the same as the 1020, except it has 4 megabytes of flash built in. So you don't need an external QSPI flash chip. I'll say though, like the pricing isn't like it's not good enough in my opinion. Like I would just take the 1020 because then you can stick whatever chip you want. But if you're like spacing constrained, because it is 144 LQFP, this is a big ass chip. You can get, of course, the version that has the flash, bonded inside. And then after the 1020 series, you actually get into like the pretty like not like suddenly pops up to like very advanced peripherals. So you're still going to be looking at 500 600 megahertz, right? But the SRAM gets huge, 500 or even 1 megabyte of SRAM. This one, the 1064, even has that flash memory built in. There's a GPU, the graphics acceleration, and it has parallel display interface. So this is parallel TFT out. So that's a 24-bit TFT display with H-Sync and V-Sync. Of course, you can always run SPI displays, but if you want like a 7-inch, 10-inch display, 8-inch display, 10-inch display, basically everything before LVDS or MIPI, parallel is your way to go. This still will, the 1040, 1050, and 1060 are still going to have the I2C SPI peripherals, but they're going to add CAN and built-in Ethernet. Now, for the Ethernet, you'll still need a PHY. It's just like the low level. It's not the low level part of Ethernet. It's like the software side of the Ethernet, and you'll still need a TLS stack and like LWIP or whatever to run the Ethernet. So, I know people who've used the Teensy, which is I think the 1050 and 1060 series. There's code there for controlling the Ethernet peripheral. And then, another thing that's interesting, once you get to the 1050, 1060, 2 USBs, so you can have one host, one peripheral. And by the way, these are all high-speed USB. The 1010 even has high-speed USB. So it's impressive because it's rare to see high-speed USB in a microcontroller. Usually it's full speed, like the ESP32, RP2040, SAMD series are all full speed, not high speed. So let's show really quickly the chips on the overhead. If it's possible to go, thank you. So I don't have a ton, I'll be honest with you, but I have a couple 1010. So this is the 1011. So this is what the 80 LQFP looks like. It's designed for a 2-layer board. Go to 4-layer, of course, for easier routing, but you can absolutely make it work on a 2-layer because I did it. 4-layer will just, make it easier to route all the pads, and of course you can route them underneath. This is some 1062s. I've got a couple. So BGAs, pretty, I think these are 0.8, so they're not super fine pitch. You'll need to fan them out, but it's not too bad. The 1060 series. And then let me see what else I've got here. I've got some 1051s, just like 5. Maybe this is the 0.8. Oh yeah, sorry. Totally different. So you can see the difference in the BGAs. So sorry, I think this is the 0.8 pitch. Check the data sheet though. This is like 0.5 or 0.4 maybe. No, 0.5, 0.6. So this one's going to be a lot easier to route. Still 4-layer. This one you might have to go with a 6-layer board for that. So nice chips. And then let me think what else I've got to show off. I've got that's pretty much it. Okay, so you've got the QFP and then small BGA and large BGA. So let's just go to Digi-Key again and I'll show you searching for them. So this is the iMX RT series. And there's lots of evaluation boards. Don't forget, you can also use a TNC to develop with these, especially the 1050, 1060. For under microcontrollers, even though again, once you get the 1060, it's actually kind of good enough you could run Linux on it in theory. So there's quite a few in stock of a few different versions, the 1052, the 106 series, a couple other it looks like there's a few from a different family. Like I said, the 1011 is in stock, lots of them, 1051, 1042. So 1062 is over here. So if you are interested in playing with these, especially, like I said, the 1011D, 1011C, there's also an evaluation board. RT 1011. Let's see if they have an evaluation board. I did purchase one, but I don't know if it exists anymore. Hold on, let me see what this is called. I could also be incorrect. Oh, and by the way, I think, wow, this one has a Freescale logo. I guess this used to be Freescale. Yeah, I have this a 1011D dev board, but it looks like it may not be available anymore. But this is what it looked like. It had, oh, sorry, can you go to the overhead? The iMX 1010 EVK. Oh, so you know what? Maybe I'll search for 1010 EVK. 1010 EVK. And let me see. Oh yeah, can you go to the computer? So that's what it was under. Thank you. They do have them in stock. It's called the 1010 EVK, but again, comes with the 1011, less than $50. Comes with, debug port, crystal, looks like a WM8960, so an I2S codec for microphone speaker, and Arduino headers. So the one I recommend pick this one up if you're interested, but the one I'm using is the 1011D. So this is my pick for the great search.
And that's a great search.
That's right.
Where in the world is that part I need? The great search with Digi-Key.
Alrighty, some questions. Are you ready?
Yes.
Okay. With boards just coming back in supply like this M7, are you having challenges with other components like LDOs, etc., being stocked for everything?
No, the LDOs are actually also totally in stock again and at a reasonable price. Some motor controllers are back at a reasonable price. Everything's back at a reasonable, not everything, but many, many, many things are back and at a reasonable price at this time.
All right, next up. I know you said this board design has been on hiatus for a couple of years due to shortage, but how much time do you think you've actually put into this? Curious how long it takes for a board designer to make a board.
I think, I've probably put maybe, 20 hours into this board so far, but it's like a very focused, that doesn't count like the researching and like speccing parts and like the historical time that I've spent. But yeah, 40 hours total.
Okay. Any idea when the Feather M4 Express will be back in stock? I saw my script saying August, September.
I know.
Last times, but I was curious if it'd be sooner since you had a back order for forever. And
I do have it back forever, but I really don't know. The SAMD51s are some of the only chips that I'm really struggling to get. The SAMD21s, actually, we just are getting, there's a shipment on the way, which makes me think that all the SAMD21 stuff will finally be back in stock, like Circuit Playground Expresses. But the SAMD51s are still like ludicrous.
Okay. Any plans for a SAM E51 Metro? There's a bunch of stock of Digi-Key in the 100 TQFP package right now.
I just have to. The thing is, I'd have to redesign, and by the time I redesign it, like I'm not going to get chips. So, and
Okay.
yeah, basically, I'm just going to wait.
Next
But we
up.
might have I think we did get some SAM E51s for the Feather. So ironically, the Feather M4 can I think will be in stock soon.
Okay. The Metro M7 has 128K SRAM. Is there any chance the Feather version will use external SPI RAM for a larger memory space?
I don't believe it can map external SPI RAM.
Okay. And question, what is this board's happy voltage range?
This is a 3.3 volt chip.
All right.
All the Cortex M series are going to be 3.3 volts. That's their kind of preferred voltage range.
Okay. I think. Oh, could the M7 chips do basic video streaming? Theoretically?
I mean, not like encoded, like not MPEG decoding. Well, maybe. I mean, they're really
So no. So check.
at 500, 600 megahertz, on an M7, the problem is you have to have the memory to cache it, right? It's not a processor speed. I think it's a workspace, memory workspace issue. So it has the horsepower, right? Because like, I think it's got the speed for it, but, I don't know, you'd have to have it be encoded in the right way. And of course, it would have to have it all, if you have to DMA it, but you theoretically could. I think that these chips, especially the 106 series, could theoretically even run. I think they can run Linux, and I wouldn't be surprised if there's a small distro that could run, and then, that would be the way to do it. It's not optimized for video, but could probably do it, but it would be a lot of work.
Okay, well, Adafruit have ADS1115 ADC. Does it have shortages?
The ADS1115 is in stock.
Okay.
Yes, I'm pretty sure.
All right. And are we launching a line of branded baby toys for young makers? Well, we're probably going to start off with showing how to mod existing ones, and then we'll see where that goes. Because it'd be kind of cool to have someone do open source, hackable, moddable, non-privacy invading infant toys.
Yeah.
But we'll see.
Okay.
We'll see where these waves take us. All right, so that is our show for tonight, ladies.
Yeah. Okay.
Thanks so much, everybody. Thank you so much to our team, our community, everyone who keeps us going. And thanks to little kiddo here, who
thinks I'm big.
who is fascinated by all of the mom Ladyada images all over the screens,
I know.
but managed to hang out and just help me press the buttons here.
Yes.
So that is it. We'll see everybody next week. Thanks so much. That is your Desk of Ladyada.
Thanks, everybody. Good night.